Just looking back at part 1, I made a mistake when writing this. These absolute value signs should not be here. I did not say absolute value for the second derivative, but I accidentally wrote that. So just to clarify, those are not there. And I'll just rewrite this as second derivative equals a negative 32 feet over second squared. I'll just kind of cross this one out. And this is our correct answer for second derivative. Now going on to part B. About how long does it take the object to hit the ground? And so we have our position function, s equals 166 minus 16t squared. And all we do for this is we solve for t. So when we set that up, we have 166 minus 16t squared equals 0. Then we get 166 equal to 16t squared, which then, when we go next step, 166 all over 16 is equal to t squared, since I divided by 16 there. And then to get rid of this, we're just going to take the square roots. So t then is equal to the square root of 166 all over 16. And when we solve that, and we get it's said to round to the nearest tenth, so I got t is equal to approximately 3.2 seconds. And so to find the time, all we do is take our original function at the beginning of position and we just solve for t. And t, also when we take the square root of something, we usually get a plus or minus answer, but the time is always positive, so we use a positive answer. And then part C, the last part, asks, what is the object's velocity at the moment of impact? And we solve this simply by taking our velocity function that we got earlier and times by t. So when we look back at this, I'll pull this back up from our original sheet, velocity was a negative 32t, so the velocity t. So we have a negative 32 times t is going to give us the object's velocity at the moment of impact. So I'm crossing this out because we're going to use the function we got from solving the velocity. So a negative 32 times t, so we take a negative 32 times the time we found earlier, which was approximately 3.2. And when we get that solved, we get a negative 102.4, and our label is feet per second. And again, I rounded to the nearest tenth with this answer as well. So the object's velocity at the moment of impact is a negative 102.4 feet per second. And this is how you solve the 3 parts of problem 5 from section 3.4 homework.